In this video I will talk about two sample confidence interval. Right, that is, you have two samples from two different populations, and you're interested in drawing up inferences about certain parameters. I will talk about four different confidence intervals. One of them is the following: 100 times 1 minus alpha percent CI for the difference in population mean and population means when population variances right or not. Okay, so what this means is that suppose you have, say, two different populations, say all men in the UK and all women in the UK, and you are interested in comparing the average weight of all men in the UK and the average weight of all women in the UK. Alright, so this is, and here we are assuming that the population variances of the average weight of all men in the UK and that of women in the UK are known, but usually that is not the case. But anyway, for simplicity, let's assume that the population variances are known, and we are interested in the difference between the population means. Number two, 100 times 1 minus alpha percent CI for the difference in population means when population variances are known but equal. Alright, I mean, once again, this could be illustrated by the same example, that you have a population of all men in the UK, population of all women in the UK, and you're interested in comparing the weight, the average weight of men in the UK versus the average weight of women in the UK. Okay, but here we are assuming that the variances are known but they are equal. Right? Again, this may not be a realistic assumption. The case 3 I will consider is this. when population variances are unknown and not equal. Okay, so that's case 3. And finally, case 4, I shall consider is the following. Okay. So when I say a difference in population proportions, I mean, you could think of an example where you have all men in the UK and all women in the UK, and you want to know what percentage of each population smoke. So for example, so you want to know like what proportion of men smoke and what proportion of women smoke. And you want to compare the two proportions, whether the men smoke more than women or whether women smoke more than men. Alright? So in each of these 4 cases, I will give you a confidence interval. I will show you the derivation for the first one, for the first of the 4 cases. For the 3 remaining cases, I will just write down the formula for the confidence interval, but will not show you the derivation. But for the first one, you will need to know how to derive. Okay? Okay. So number 1. So this is the 100 times so 100 times 1 minus alpha percent confidence interval. The difference in population means when the variances are known. Okay. So I'm going to suppose x1 to xm are IID, normally distributed, with the population mean being this, the population variance being this. I'm also going to suppose that you have another sample, y1 to yn, IID. Assume that x Alright. Okay. Now, given these assumptions, I'm going to show you how to derive 100 times 1 minus alpha percent confidence interval for the difference in the two population means, that is mu x minus mu y. Alright. Now, let x bar denote the sample mean of the first sample. Okay. And let y bar denote the sample mean for the second sample. Now, if you look back in the video for normal distribution, we did that some time ago, that one of the properties of the normal distribution I gave you is the following. Okay. All right. Now, so these two follows from the properties of the normal distribution. All right. And because of the fact these two are independent, because we assume that these two samples are independent, another property that I mentioned in the same video is the video on the normal. You can say that the difference of two independent normal is also normal with the parameters okay. Right, so all these three properties follow from the properties on normal distribution. Okay. All right. Next, I'm gonna subtract this on the left and the right. So you will get okay. Now if you divide the left and the right by the square root of this, you will get this. Right, this is, you get the standard normal with zero mean and variance equal to 1. Alright, now you may recall from the video I did on the percentile of the normal distribution. That if you have a standard normal, excuse me, not being able to draw nicely. So if you have, say, 2 points, so this is the PDF of standard normal, okay? And if you have 2 points on the horizontal axis, right? So suppose this one and this one, right? And suppose this point is z 1 minus alpha by 2, and suppose this point is z alpha by 2, right? I hope you remember the definition of a percentile. So what this means is that this to the area to the left of this point, you have an area of 1 minus alpha by 2, and to the left of this point you have an area of alpha by 2. So this area is alpha by 2, and because the area to the left of this is 1 minus alpha by 2, the area to the right must be alpha by 2. Okay, so the area between the two, between this point and this point, the area between the two must be 1 minus alpha. Alright, so I'm going to use this fact to construct a confidence interval, right? So in the next step, I'm going to say that because this has a standard normal, it follows that the probability that this lies between these two must be 1 minus alpha. Alright, so that's what I will say right now. Okay. Okay, so let me say that right now. So this implies from the picture that I just drew, okay, the probability that this guy here is between this So the probability that this is between these two must be equal to 1 minus alpha. Alright, so now what I'm going to do is I'm going to rearrange this statement as a statement on mu x minus mu y, because we are looking for a confidence interval for mu x minus mu y. Okay, so this is this. Rearranging this, right? So you see what I've done? I have rearranged it as a statement on the difference between the two population means. Right? In the next step, I'm gonna use the following fact, which I mentioned in the percentiles video. You may recall this, that because of the symmetry of the standard normal PDF, the following, this statement is true, right? Right, that is Z alpha by 2 is minus of Z 1 minus alpha by 2. Okay? Right, so this becomes equal to okay. Alright. So this completes the derivation for the 100 times 1 minus alpha confidence interval for mu x minus mu y. Right? So just to conclude, right? The 100 times 1 minus alpha confidence interval for the difference in population means is the following. So the lower limit is this one, which is x bar and the upper limit okay. Alright, so this is the case 1 of the 4 cases I'm going to consider for 2 sample confidence intervals. Alright, so the second case I'm going to consider is the following. So number 2. Okay, so here this is the same as case 1, except we are assuming that the population variances are unknown but equal. Okay. So suppose So you have a sample from a normal population with the mean equal to this, variance equal to sigma squared. And once again, I'm going to assume that the two samples are independent. And I assume also that sigma squared, which is the common population variance, is unknown. Okay. Now, I'm not going to show you the proof of the confidence interval. I will just write down the result without the proof. And I don't expect you to know the proof. Okay, that's 100 times 1 minus alpha percent Ci for the difference in the population means is given by the following: x bar minus y bar so that's the lower limit. The upper limit is this is the upper limit, right? And these two are the percentiles of this t-distribution. I showed you how to read them. If you look in the video on percentiles, you will see. And SP is known as the sampled, I'll write them down in a sec. It's defined by this expression. So this is the formula for SP and is known as the sample It's known as the sample pooled standard deviation. Right. Okay. Right. So that completes case 2. Case 3. So this is the most general of the three cases. So here you're looking at the confidence interval for the difference in population means when the population variances are unknown and not equal. Okay. Okay. So we're going to suppose suppose too that we have a second random sample. Okay. And we're going to assume that the two samples are independent. And we're going to assume also that unknown and not equal. Okay. So once again I'm going to write down the confidence interval for the difference between these two without showing the derivation. Okay. So 100 So this is the lower limit, and the upper limit is going to be the upper limit, where once again this one and this one are the percentiles of the t distribution, which I talked about on the percentiles video. Now the A is defined as follows. A is given by the following expression. So just be with me. Okay, so this is the expression for A. And Sx squared is the sample variance for the first sample, and Sy squared is the sample variance for the second sample. So let me write that down. So Sx squared is simply the sample variance, the unbiased version, so I divide by n minus 1. Right, and Sy squared is the sample variance for the second sample. Okay, so this is case number 3. Now the last of the 4 cases, which is case number 4, is this one. So this is case 4. So this is 100 times Ci for the difference in population proportions. Okay. So just to recall the example that I gave you earlier, that you could have 2 populations, say all men in the UK and all women in the UK, and you are interested in what proportion of each has a certain characteristic. So for example, what proportion of men smoke and what proportion of women smoke, and you want to know how they compare. So that's where that is where a confidence interval like this one will be of help. All right. So suppose so we have a sample from a IID Bernoulli. So Px denotes the population proportion. And another sample IID Bernoulli. So PA with proportion Py. Alright. So we're going to assume that x1 to xn right? Now, so Px here, as I said, Px is the population proportion for the first sample. and PY is the population proportion for the second sample. And we are assuming that they are assumed to be unknown. So both Px and Py are assumed to be unknown. Okay. So the question here is to find a confidence interval for Px minus Py. Right? So the difference in. So once again, I will write down the result without proof. This confidence interval is an approximate one because it uses a certain approximation, which I will not talk about, right? Namely, it uses a central limit theorem approximation, right? And is given by the following. So this is the lower limit, and the upper limit is so this gives the 100 times 1 1 alpha confidence interval for the difference in population proportions. Where x bar is the sample mean or the sample proportion in this case. And y bar is the sample proportion for the second sample. Okay. Alright, so this completes the 4 confidence intervals for the 2 sample problems. And in the next video, I shall talk about a new topic, which is known as the test of hypothesis.